Hi everyone and welcome back to yet another episode with Moments with Chemistry. And today we are going to continue with our 2018 A-Level English Medium Chemistry MCQ Reviews. And today we have planned to complete from question number 11 to question number 20. Okay, question number 11. The increasing order of the boiling points of the following substances: helium, methane, CCl4, CBr4, SiH4. Now you know that the boiling point of a certain compound depends predominantly on what? On the strength of intermolecular attractions. Okay? It depends upon the strength of intermolecular attractions. So if you look at these 5 compounds, all of them have latent forces as their predominant type of secondary intermolecular attractions. So now we have identified the type of intermolecular attractions. Now we have to identify the strength of intermolecular attractions. You know that when the molar mass of a particular compound increases, the effective surface area of the particular compound increases. So therefore the number of London forces that the particular molecule can accommodate with the adjacent molecule increases. Thus what happens? Boiling point will increase. So the one with the highest molar mass eventually will have the highest boiling point. So the highest molar mass is CBr4. Then now highest one is CBr4 now, and then the next one will be CCl4, then SiH4, then CH4. Last will be helium because it's the one with the smallest molar mass. Okay, helium, CH4, SiH4, CCl4, CBr4. Your answer will be answer number 3. For question number 11, your answer will be answer number 3. Okay. Question number 12. Identify the correct statement from the following. Among the electronic transitions n equal 2 to n equal 1, then n equal 3 to n equal 2, then n equal 4 to n equal 3, in a hydrogen atom, most energy is released. You know that the quantity of energy that is released when a certain electron or when a photon goes from a energy level of higher energy to lower energy, it releases energy, and that energy falls within what region? The visible region. That is why you can see colors. So you know that E equal to h nu, the Max Planck equation. Okay, E equal to h nu. And you know that what? The greater the gap between the two adjacent energy levels, the greater will be the quantity of energy that's released. So if you look at this, if this is n equal 1, n equal 2 will be of a higher gap, n equal 2. Lower than that will be n equal 3. Finally we will have n equal 4. Now we'll try to draw the relevant transitions that these people have given in the question. N equal 2 to n equal 1 is this transition. Okay. Then n equal 3 to n equal 2 is this transition. Then n equal 4 to n equal to 3. So you know that the greatest gap is between n equal 2 to n equal 1. So therefore, the greatest energy that is released when a photon jumps from an energy level of higher energy onto an energy level of low energy will be the transition between n equal 2 and n equal to 1. So the transition between n equal 2 and n equal 1 will be the one that carries the highest amount of energy. Okay, so the first one is wrong. Among the species OF2, OF4, OF2, OF4, SF4. Least stable is SF4. No. What is the least stable? OF4. Why OF4? Now if you look at OF4, octet is completed around oxygen. That's true. But 1, 2, 3, 4. Now oxygen is from group 16 now, so it should have 6 electrons in the outermost electron. So if you look at this 1, 2, 3, 4, theoretically if you go to draw, they really need 2 more electrons, no? Because the 2 electrons that oxygen has, it cannot vanish, no? But If you count the number whether it's going to satisfy the octet, you can see that oxygen is exceeding the octet. It becomes 2, 4, 6, 8, 10. But oxygen is in period number 2. It cannot exceed octet. Why? It doesn't have any d octet. So therefore this OF4 is going to become a hypothetical compound which doesn't exist. So therefore its stability will be the least. Others all are okay. OF2, we have learned this under inorganic chemistry when the oxidation states of oxygen, that table is given. Then SF4, which has a seesaw shape. SF4 has seesaw shape. So those are direct ones. Next one. Among the elements, lithium, carbon, nitrogen, sodium, potassium, least electronegative element. You know that across a period, the electronegativity decreases. So the least electronegative element should be the one that belongs to group 1. So that is sodium. And down the group, electronegativity decreases. Across the period, increases. So for it to be the lowest electronegative element, it should be more towards the left and more down. So the answer is sodium. Next one. The following pairs. Now look at this. Lithium, fluorine. Lithium plus. You know, if it's lithium plus, it goes to helium configuration up here. Okay. Lithium plus. Then F minus goes to neon configuration. Then O2 minus also goes to neon configuration. Okay. The difference in radii is greatest between Li plus and O2 minus. If you look at Li plus, it is from a completely different period, and O2 minus is from completely different period. So therefore their difference is greater instead of any other one. Now if you look O2 minus and F minus, the difference in their atomic radii, both belong to the same period. So therefore the difference in the atomic radii is not going to be very substantial. But if you look at Li plus, which has the electronic configuration of helium, where one entire shell is removed, and O2 minus, which has the electronic configuration of neon, these two components belong to two different periods. So therefore the difference in the radii between those two components will be the greatest. So that is correct. Now look at the fifth one. The only type of intermolecular attraction or force present in CH2Cl2 in the liquid phase is dipole-dipole forces. Wrong. Any chemical system has London forces. Any chemical system has London forces. So since they say it's only dipole-dipole attraction, it's wrong. Even London forces are present in CH2Cl. Okay, next one. CH4 gas giving you CH3 gas and H radical. Now this one, CH4 gas, look, CH4 gas should give you CH3 radical and H radical. So what is this enthalpy? How do you define this enthalpy? Yeah, this is at the standard state. So this particular enthalpy will be the enthalpy change that is associated with the cleavage of one CH bond, because only this CH bond is cleaved in order to form this. Standard enthalpy change for dissociation of the first CH bond. Dissociation of the first CH bond. Second one, atomization enthalpy of methane will be what? CH4 solid to CH4 what? Gas. That is atomization. Or CH4 solid giving you C solid and H gas. That is also atomization. Next, first ionization enthalpy of methane. Actually, we cannot speak about first ionization energy when it comes to compounds. First ionization energy is actually a character that belongs to elements. Standard bond dissociation enthalpy change of methane means all four bonds should be cleaved, but here only one bond is cleaved. Standard radical formation enthalpy of methane, there's nothing like that. So that's also completely wrong. Okay. Now the 14th one. It's also a very nice question. It actually assesses your knowledge on chemical kinetics, then your knowledge on chemical equilibrium, and your knowledge on gases. So your knowledge pertaining to three different physical chemistry topics is going to be assessed in this question. Okay. The elementary reaction to a gas giving you B gas In a closed rigid container at constant temperature, initial pressure of the container P naught, and when the rate of the reaction is 50%, when the rate of the reaction is 50%, the pressure is PT. Okay. Now, you know that when you consider these two gases, these two are within the same rigid molecule, same rigid container. So therefore, V will become constant. Okay. And then they are conducted within the same temperature. So therefore, PV equal nRT, assuming ideal behavior. When V is constant, T is constant, anyway R is constant, so therefore P will be directly proportional to N. Okay. Okay. So if I consider the initial number of moles of A gas to be N, final number of moles of A gas, assuming X to be dissociated. So if X dissociated from A, how much of B will be formed? X by 2. And we know that P naught, okay, then total N final will be N minus X plus X by 2, that is giving you N minus X by 2 at the I. Then according to this proportional relationship, P naught directly proportional to N, P naught directly proportional to N, PT directly proportional to N minus X by 2. Haridhar. And you know that since this is an elementary reaction, rate equal to K into A gas concentration square. And you know that N is directly proportional to concentration, so therefore P is directly proportional to concentration. Okay. P is directly proportional to concentration. So rate is directly proportional to K into A gas squared. Okay. And when the rate is 50% means when the rate becomes half of the initial value. So instead of this A gas squared, I am very much privileged to put a K dash here because R and all will also come there now. So putting K dash here, I can write it as P naught squared. Okay. Instead of A gas concentration squared, since we know that P is directly proportional to C, looking at these two relationship, I can come out to the conclusion that wherever I have an A gas concentration term, I can come and plug in P naught value. Okay. Then when the rate is rate by 2, K dash should now be, the K dash value should now be directly proportional to what? To the final number of moles of A. So what is the final number of moles of A? N minus 6. N minus 6, no? Final number of moles of A, N minus 6. Okay. So now we have to try to manipulate and get a value for this N minus X. So how will I get that? Now look at this. From these two equations, if I try to minus the first equation by the second equation, I get X by 2. No? I get X by 2. So X by 2 directly proportional to P naught minus PT. So X will be directly proportional to 2P naught minus 2PT. Okay. What did I do here? From these two relationship, I just wanted X by 2 minusing these two. So I get here P naught minus PT, so I get a value for X. Now in this what? In this P naught, X is this one. Okay. So if I divide these two, I am left out with 2 equal, this 2 will go off. P naught square divided by N. Instead of N, what should I write? P naught. Minus, instead of X, what should I write? This one. 2P naught plus 2PT square. Okay. So 2 equal to P naught square divided by 2PT minus P naught and square. But the question asked us, the question is asking us, question is asking us Pt by P naught. Now what can I do? Now from this equation, I'm going to take what? I'm gonna take the square root. So square root of 2 equal to P naught by 2pt plus P naught. So 2 root 2 pt plus root 2 P naught equal to P naught. So 2 root 2 pt equal to 1 minus root 2 P naught. So pt over P naught equal to 2 root 2 by 1 minus root 2. 2 root 2 by 1 minus root 2. Question is asking, sorry, other way around. Pt by P naught equal to 1 minus root 2 divided by 2 root 2. Okay, okay. So this is, so your answer will be answer number 3. So for question number 14, your answer will be answer number 3. 15. An equimolar aqueous solution of weak acid HA and HB of 1 mole per cubic decimeter in each acid with pKa values of 4.7 and 5 respectively is at equilibrium. The value of A minus B log A minus concentration divided by B minus concentration approximately equal to. Right. We look at this. Okay? Okay. So now you know in that particular solution we have both HA and HB. So if I write the equation for HA separately, what will come here? HA, H plus aqueous plus A minus aqueous. Okay. Okay. Now I'm gonna write the equation for HB. Look at the equation for HB. The equation for HB will be aqueous giving you H plus aqueous concentration plus B minus aqueous concentration. Okay? Okay. Now, okay. Ka1, this is Ka1, this is Ka2. Ka1 equal to H plus aqueous concentration, into A minus aqueous concentration by HA aqueous concentration. So Ka1 equal to H plus aqueous concentration into A minus aqueous concentration. Why? Because HA is 1. Similarly, I can write for HB, Ka2 equal to H plus aqueous concentration into B minus aqueous concentration. Okay. Okay, now we need log A minus aqueous concentration, log A minus aqueous concentration divided by B minus aqueous concentration. So if I take log of this side, I have to take log of this side, so it will be log Ka1 minus log Ka2. But you know that minus log Ka1 equal to pKa1. Okay, minus log Ka1 equal to pKa1. So log Ka1 is how much? Minus pKa1. So minus pKa1 plus pKa2 equal to log A minus aqueous concentration divided by B minus aqueous concentration. Okay. Okay. So minus pKa1 value will be minus 4.7 plus 5. So your answer will be 0.3. So your answer for question number 15 will be 0.3, the third answer. Okay, 16. Which of the following statements about phenol is false? It reacts with CH3COCl to form phenyl ester. Correct? No? CH3COO, the resulting product will be like this. The resulting product in that particular reaction, when you reacted with CH3COCl, this Cl and this H will go out as H plus, remaining us with CH3COO benzene. Okay. Okay. It reacts with bromine water to give white precipitate. Yes. There will be bromine will get substituted to 3 positions to give you. It will be a tribromophenol. It gives a white precipitate. Evolves carbon dioxide gas when treated with NaHCO3. No, that is only applicable for carboxylic acids. Because carboxylic acids are the most acidic. So even if you put the mildest of bases, it will react and form carbon dioxide. But this is not so acidic like carbon dioxide. Okay. So that's the wrong one and that's the answer. Gives a colored compound when treated with aniline in the presence of NaOH. Yes, it gives an orange azodine. Gives a colored purplish solution when treated with neutral FeCl3. According to the new syllabus that was introduced in 2019, this is not there, but actually it is a true statement. Okay. So your answer for question number 13 will be the third. Okay, 17. Half-life of a reaction. What is half-life of a reaction? Half-life of a reaction is the time taken for the concentration of a particular component in a reaction to become half of its initial value. So what are the parameters on which this half-life of the reaction depends on? Number 1, it depends on temperature. Okay. Number 2, it depends on the order of the reaction. Okay. Then number 3, it depends on the order. Then it depends on the rate constant of the reaction. Okay. First one. Always independent of the initial concentration of reactants. Wrong. That is only applicable for first order reactions. If you nicely look at the theory, you will get it. Okay. Always dependent on rate constant for sure. For sure, always dependent on rate constant. Why? Rate constant is the indication for what? The order of the reaction. So therefore, it's surely depending on this rate constant. Always independent of the order of reaction. No. At certain instances, it depends on the order of the reaction. First order reaction, but 0.693 over K equal to T half. For first order reaction, T half equal to 0.693 over Ln2 divided by K, the rate constant. So here, there's nothing to talk about the concentrations. Okay. Always independent of temperature? Never. Dependent on temperature. Equal to twice the total reaction time. Not always. Only if the reaction is zeroth order reaction, there will be equal drops in concentration. There will be, when it's a first order reaction, there will be equal drops of concentration for equal time intervals. Okay. Only then you can consider it to be 2 times. But when it goes to 4th order, 5th order, it comes as curves. So therefore, when concentration becomes, let's say, it differs by a factor of 2, there is no compulsion that the time the reaction proceeds should also be multiplied by 2. Okay, so 17, your answer will be answer number 2. 18. Electromotive force of an electrochemical cell doesn't depend on. What is the electromotive force of a chemical cell? E cell equal to E cathode minus E anode. So the nature of the electrolyte, does it dependent on the nature of electrolyte? Yes. If you put H2SO4, the reaction will be something else. If you put HNO3, reaction will be something else. So according to the reaction, cathode and anode changes. So therefore E cell also changes. Temperature, for sure. If you increase the temperature, what happens? EMF increases. Why? Electrons that go slowly will now go faster. Okay. Concentration of electrolytes, yes. Concentration of the electrolytes gives us an indication of the total number of moles, that is the total number of a particular ion that is awarded to the aqueous solution by the particular electrolyte. So if the concentration is greater, the amount of moles is greater and therefore the EMF is greater. Surface area of electrons. surface area of electrons. No. Surface area of electrons, even if you use a huge copper rod or even a small copper rod, there's nothing, because you know that electromotive force is some type of a pressure generation. So pressure is force per unit area. So only looking at surface area is not going to work. Okay. But the surface area is going to affect at the time when you take the equilibrium. The time the reaction takes to attain equilibrium will differ with the surface area. Okay. Type of metal that form the electron, obviously when it's zinc it has a different T psi value. When it's copper it has a different T psi value. When it is any other metal, it will have a different T psi value. Okay. So your answer for question number 18 will be answer number 4. Okay. 18 answer is answer number 4. Okay. 19. Iodate ion. Now this is very simple. It actually assesses your unit 3 knowledge. Iodate ion oxidizes sulfide to sulfate. Now look at this. Sulfide SO3 2 minus, 2 SO4 2 minus. Okay. Plus 4 to plus 6. So the electron transfer is 2 electrons. Iodate goes to I2. Iodate goes to I2. Okay. We don't know actually to which component it goes. We know only this. Then the mass of KiO3 required to totally oxidize the amount of Na2SO3 present in 25 cubic centimeters of a solution of Na2SO3 to Na2SO4 is okay. So you know the number of moles of Na2SO3. Number of moles of Na2SO3 will be equal to the number of moles of SO3 2 minus. So 1.07 grams divided by So the number of moles of Na2SO3 is going to be 0.5 over 1000 into 25. So this is 12.5 into 10 to the power minus 3. So number of moles of iodate equal to the number of moles of KiO3, that is equal to 1.07 divided by this is 16 into 3, and potassium is 39, 127. So if you go to add this 8 204. So this is 204. So this is like 170 to 2 now. So 170 to 0.01, 170 to 2. So this is 0.005. So that is 5 into 10 to the power minus 3. So if you look at stoichiometry, 12.5 into 10 to the power minus 3 should be for the number of electrons that is exchanged by that IO3 minus into, when you multiply IO3 minus, it will be 2 electrons. 5 into 10 to the power minus 3. Hi there. So if you multiply these two, you are getting 25 5x. 5x equal to 25. So x equal 5. So from iodate IO3 minus IO3 minus that has plus 5. If you, now this is gaining the electron now. So here you have to release 5 electrons, so giving you the final oxidation state of 0. So the final oxidation state will be 0. So for question number 19, your answer will be 0. Answer number 2. Okay, question number 20. Which of the following statement regarding the S block of the elements in the periodic table is false? Okay. First one. All elements in group 1 react with water liberating H2 gas. Yes. Although lithium is very slow, we can't actually neglect it. So lithium also has a substantial amount of the rate of reaction such that H2 is released. Okay. All elements in group 1 except lithium react with N2 gas. That is wrong. It should be the other way. All elements except lithium from group 1 do not react with N2 because lithium has diagonal relationship with magnesium. No, that is why it reacts with that N2 gas. All elements in group 2 react with N2 gas, yeah, forming the corresponding nitride. Now, for example, magnesium plus N2, Mg3N2. Na reacts with excess O2 to give Na2O2, yes, the peroxide, and potassium gives you the superoxide. That's also correct. All elements in S block are good reducing agents. What is a reducing agent? For it to act as a reducing agent, it should have the ability to undergo oxidation. Ability to undergo oxidation means it should have the ability to release electrons. So who are the people who are good at releasing electrons? Metals. So S block elements are all metals. So therefore all of them act as good reducing agents, which means it's easier to remove the electron from them. Why? They want to attain a noble gas configuration. But how can they attain that noble gas configuration? By removing electrons. So your answer to question number 20 will be answer number 5. Question number 20, answer number 5. Okay, so this marks the end of the second episode of the 2018 paper. So hope you enjoy, and don't forget to share, like and subscribe, and press that notification bell so that you will be informed of our future videos. So stay tuned for more and stay safe.